Well, hi everyone. We are going to look at some trig applications, and we're going to be on page 455. We're just going to work on 3 problems. And the first one is 107 here, and there's the problem. It might be easier if you're looking up your own book there, because I think I'm going to have to move the book here in a minute. But what we see is the average high temperatures in degrees Fahrenheit in Boston and in Fairbanks for selected months, and this was in 2015. So, I want to show you how to do this part A here. Use the regression feature of a graphing utility to find a model of the form y equals a times sine of b times t plus c plus d. So we got to figure out a model that would have a value for a value for b, a value for c, and a value for d in it. So, I'm going to enter the data, and I want to show you how to do that. Hit the Stat button, turn it on, hit the Stat button, and in the Edit mode, which is where it goes to right away, that's what we want to do. We can put numbers in list. The first number I want to put in, T is standing for the month, and January stands for 1. T equals 1 corresponds to January. Then we have a March, which would be the 3rd month. June is the 6th month. August is the 8th month. And November is the 11th month. So I've got in L1, in column 1 there, I've got the month numbers. I'm going to just do Boston. Now for Boston, we have 33 is the January temperature. 41 is the March temperature. I want these to be lining up in the table. 72 is June. 83 is August. And 56 is November. So, I've got it entered in here. I'm going to hit the Stat button again to get the new menus here. And then I'm going over to Calc. Cursor over to Calc here, and these are all regressions here after the first 3. Linear regression, quadratic regression, cubic regression, quartic regression, a different form of linear regression, natural log regression, exponential regression, power regression, logistic. Now here's what I wanted, sine regression, because this is a sine formula. So what we're going to try to do is get a model, an equation that will follow the points here, 133, 341, and so on. So I'm going to hit sine reg, and I have it in L1 and L2, but if you look, if I hit second and then 1, that blue symbol, it says L1. So second, whoops, I hit the wrong thing. Let me quit. Okay, sine reg, and then second, L1, and then the comma is right above the 7. The key above the 7 is the comma. These are where my 2 columns are, my 2 variables. L2. And then I'll hit enter. And you'll see this is the same thing they've got, except they have a T instead of the X. Okay, and I'm going to write down the equation that we get from our display here. The A value. So Y, that stands for the temperature. The A value, I'm going to go 4 decimal places and go 24.5927. That's what the A value is. The B value is 0.4946 is what I'll use. But we have the sine, 0.4946, and that is the coefficient of t. Our calculator is calling it x. 4946 plus C, and C is negative 2.2619, and plus D, and D happens to be 57.3868. Now that's that first column. This is the Boston column. Okay, I'm going to move the book so I can write. Okay. Now, I also want to show you something else. Okay, so we're talking months. I'm going to set my window. I'm going to go 0 to 12 on the months, and then go by ones there. Now the temperatures, if you look, 1 is the lowest for Fairbanks, so I'm going to go 0. Wow, in January, 1 degree Fahrenheit was the high temperature for the whole month of January in Fairbanks. Okay, I'll go 0. 83 in August in Boston's the high there, so I'll just go 0 to 90 and scale by tens. I'm just kind of setting the y-axis and the x-axis, and I'm going from 0 to 12, and I'm going from 0 to 90, and just setting the scale. That's all I'm doing with this right now. Now, I could plot those points, and I'll show you how. If I hit second, and then the y equals is also stat plot. And if I turn the plot on, I've got this first option here is a scatter plot. And this is a times plot. This is a histogram. Box and whisker plots, I don't know if you remember those from previous courses. But I'm going to hit graph, and you can see the points that are on that were actually put into the table from the table. All right, now I'm going to hit the y equals button because I want to put this graph in. I've got 24.5927 sine 0.4946x minus 2.2619, close those parentheses, and then add 57.3868. Now I'm going to hit the graph button, and I want to see how closely it follows those. Not at all. Okay. I was going to say this and I forgot. When I see something like this and we're talking sine, I really wanted this to be in radians. Let's just take a good look, and guess what? It was in degrees. So I'm going to change it to radians, and now I'm going to graph it. All right, that is much better. Look how nicely it goes through those points. So this equation is modeled very well, models the plot very well. Okay. So we've got our model, and you can plug these in, but they want well, for Boston, they want February, April, May, July, September, October, December. Okay, so they want all these months. I don't know if you're thinking what I'm thinking. How about we consider using the table? Let's see what the table's set up at. 1, go up by 1s, that's fine. Okay, so we knew we had the first month. The second month is February. Let's just round to the nearest whole degree. So February, let's go 34 degrees. April is the 4th month, 50.5. So we'll go 51 degrees. Let's see, May is the 5th month, 62.5. I'll go 63 degrees for May. July is the 7th month. Let's go 80 degrees for July. September's the 9th month, 77 degrees. October is the 10th month, that's 68 degrees. And December is the 12th month. I don't know why I had to think about that so long. That is 45 degrees. All right, so that kind of takes care of Boston. What I'd like to see you do is give it a shot for Fairbanks. And in the same viewing window. So what I would encourage you to do is this. You can go to, you could redo the table and just get a new equation, and that would be fine. But if you recall, where did I go first? I hit Stat, I hit Edit. Now the first column still is those months that we had there. The second column you can change using the Fairbanks numbers. Okay? And go through, see if you can get an equation like this for Fairbanks. And when you hit y equals, come down to the, figure out what the equation is, put it in y2, and then when you hit graph, we should see 2 of them. You don't have to put the points on if you don't want. I just wanted to show you how nicely this model goes through these points. All right, and then answer part C after you get these numbers for Fairbanks. Answer part C, which is just making some comparisons with the temperatures, looking at the 2 graphs, looking at the 2 curves that you'll have. Okay. Now, let's look at 108. 108. A company that produces snowboards forecasts monthly sales over the next 2 years to be this. S equals 23.1 plus 0.442 T plus 4.3 cosine of pi times T over 6, where S is measured in thousands of units. So S is thousands. And T is the time in months. T equals 1, corresponds to January of 2017. Okay. We are to predict, I'll do A and B, and I'll let you do C and D. A, they want a prediction for February 2017. And part B, they want a prediction for February 2018. Okay. So for 2017, January 2017 is 1, so here, February 2017, t would be 2. All right. I'm going to quit and put this equation in. And it would be in radians. Whenever you see pi, I think there's a real good chance we're not going to be wanting degrees. So I got 23.1 plus 0.442x. Make sure I wrote that down right. Plus 4.3 times cosine of, now I'm going to put pi times x for the t divided by 6. Okay, I don't know why I put those x's in there. I want 2's right there. Wonder if that'll multiply. I'm going to insert a multiplication sign. And I'm going to insert a set of parentheses there. Put a 2 in that place. And delete that x. Okay. Now I've got it in. I should have put 2 in the first place. All right. What do I get? 26.134. Thousands, which translates to 26,134. 26,134. What are we doing here? Snowboards, I suppose. All right, we do the next one. If I hit second and then enter, I got that equation back. What's t here? Well, I think in 12 months, that would be 12 months after 2017, February 2017. I think we got t is 14. So I'm going to replace the 2's with 14. So 1, now I have to actually insert that, and otherwise I have to type the whole thing over. 4. Okay. I messed up. Okay, wait, let me just clear that. Second, enter. Oh. Okay. Then I have to type the whole thing in. Unless I can go up here. Nope. Okay. I goofed. So 23.1 plus 0.442 times 14 plus 4.3 cosine pi times 14. I'm going to write 14 pi divided by 6, and there I get 31.438, which translates to 31,438 snowboards. Okay, you guys can do parts C and D. And then on part E, I'm sorry, on number 109, you've got an I equals 5 times e to the negative 2t power times sine of t. Okay, this is just a calculation problem that you need to do. But if you need you could go 5 times, and then the e to the power is right here. If you hit second and you see this LN button, I hit second first and hit the LN button, and e to the power of, and then you can put that sign in. All right, I'm going to let you finish up, guys, and that will be it for your day. All right, take care. Bye.